Namaste student, this is Sanjay Nath. Today's session is on Volcanism, Chapter 7, Part 1, ICSE Standard 9. In this chapter we learn about volcanoes in detail that include the characteristics features of volcanoes, types of volcanoes, and classification of the volcanoes on the basis of their eruption and volcanic explosivity index. We'll also learn about the significance of volcanoes. Now we'll watch an introductory video clip on volcanism and their effects on us. The Earth looks so peaceful from space, but inside it is palpitating. But looks can be deceiving. If you go deep underground, one can see the red molten magma, flagering, tremendous pressure, and the earth is very different place inside. It is violently hot. The outer core molten, the inner core with 6000 degree temperature keeps the outer core molten. The thermo-convection movement which allow the magma to rise towards earth crust. The internal heat has to escape somewhere. Uprising, divergent boundary, and the convergent boundary. The heat escapes in the form of molten magma by surfacing and explode in the form of volcanoes. Violent smoke, lava, lightning, volcanic ashes. The saltic magma, thin and fluid. It creates the upper crust. The pyroclastic flow. Nothing can stop its natural fury. Join me now to study volcanoes. What is a volcano? Introduction. A volcano is an opening or a rupture on Earth's surface or crust, which allows hot magma or volcanic ashes and gases to escape through the vent. Now we'll understand what is volcanism. Volcanism, the process in which the magma is formed and moves toward the surface of the earth. A volcano. In other words, a volcano forms when a molten rock erupts or flows as lava from an opening in Earth's surface and builds up a volcanic cone. As you can see in this picture, the magma that pours out in the form of lava and slowly they pile up to form the volcanic cone. Now we'll learn about the different features of volcanoes. Extrusive features. These features are mainly formed on the earth crust or on the earth's surface. These openings are called vent. As you can see in this picture, the pipe or the capillary through which the molten magma that come out in the form of lava is called the vents. There are also small side vents or sub vents. Through this vent, volcanoes release molten rocks, ash and poisonous gas. As you can see the opening from this mouth of volcano in the cross-section view, along with the molten rocks, it also oozes out a lot of ashes and a lot of poisonous gas. All these products result from the melting in the mantle or in the crust. So what are the features of volcanoes apart from vent and other materials? Vent I have already told, the pipe through which the molten rocks flow upwards and they pile up towards either side of the volcano. Crater. Crater is the mouth of the volcano, as you can see here. This is the opening through which the lava comes out. Fissure. There is a long crack in the earth crust through which the lava flows are called fissures. Now we look upon some intrusive features made by the volcanic activities. As you can see, this is a cross-section view or 3D view of volcanic region. In this picture, we'll understand what are the different intrusive features are formed due to solidification of molten material inside the earth crust or very close to the earth crust. These shapes are mainly formed due to the solidification of magma. Now this is the main pipe through which the magma spurts out towards the earth's surface. And when the magma gets solidified in the magma chamber, somewhere over here in a polygon shape is called batholith. When the magma chamber formed, there are some space also created. These are called the cavities called xenoliths. When the molten material managed to uprise and not able to come out, instead it flow horizontally between two layers of the earth crust, will form laccolith. A little bit get bulged up. Many a time the molten material flow between the two layers horizontally, as you can see in this picture. These are called sill. When the molten material solidify across two layers diagonally or perpendicularly is called dike. The openings or the mouth from where the magma passes through is called stalk. Now we'll see all these features in the cross-section view. As you can see here, these are the volcanic structures, intrusive, and these are hypoglycal structure. These are formed due to solidification of magma in the cracks, fissures and cavities. Now we look upon the major locations of volcanic activity on the Earth's surface. Before that, you understand what is volcanism. The process by which the magma is produced and erupts on the Earth's surface is known as volcanism. There are two main components are responsible for the volcanic features to form: endogenetic mechanism and exogenetic mechanism. Endogenetic mechanism are the forces that act from inside the Earth, create volcanic features. Exogenetic mechanism are the forces that act from outside or on the surface of the earth, create volcanic features. Now we'll examine the locations where volcanoes are found on the earth's surface. Volcanoes can mainly be found at the three locations on the earth: at the divergent plate boundary, convergent plate boundary, and over hotspots. Divergent plate boundary where the two plates that diverge on the either side due to the force from inside called endogenetic mechanism. And convergent plate boundary where the two plates collide, one is oceanic plate and another one is the continental plate that rides over the oceanic plate. Due to friction between these two plates that give birth to volcanic activities. The third important areas where volcanoes are being seen is called hotspots. These are the very interesting features where there is no plate boundaries are involved. These areas where the magma uprise from deep inside the earth or from mantle called mantle plume. Over hotspot, the source of magma is from deep inside the earth where intense radioactivity is happening. Now due to this, on the thinner earth crust mainly beneath the ocean, such volcanoes erupt. These are called hotspots. Now we'll see what are the major locations of volcanoes in detail. The first one, divergent boundary volcanoes. Here the volcanic activity are mainly seen at the mid-oceanic ridges. The best example, this particular ridge is beneath the Atlantic Ocean, that's why it's called MidAtlantic Ridge. As you can see in this diagram, and this crack is mainly formed due to the series of volcanoes that form due to the oozing of magma from deep inside the earth. Here the two plates are diverging. On the eastern side, Eurasian plate is diverging, and the western side, the North American plate is diverging. This divergence of the plate is due to the magma that is pushing the earth crust beneath the ocean, and due to this, the plates are slowly diverging towards either side. Now, such volcanoes are called the divergent plate boundary volcanoes, and these volcanoes are mainly active and quiet. They're basaltic in nature, means basic in nature. They contain less amount of silicon. The examples are Krafla, Loki, Hekla, Katla in Iceland. Now we'll watch a video clip to understand how volcanic activity occurs at the divergent plate boundary. The best example is the Mid-Atlantic Ridge. As you can see in the video clip, due to the uprising magma, that magma rises from the deep inside the mantle, that managed to break through the thin crust beneath the ocean. And these two arrows are representing the plates are diverging towards either side. Now due to the pressure from inside, the magma spurts out from this crack and has given birth to the series of volcanoes beneath the ocean. And this is called the mid-oceanic ridges. Now we'll see the major locations of volcanic activity on convergent plate boundary. The best example of convergent plate boundary is the Pacific Ring of Fire. This particular plate is the largest plate beneath the ocean and is basically having series of volcanoes at the convergent plate boundary. Here the two plates are merging at one point called the subduction zone. As you can see in this diagram, the oceanic or the heavier plate sinking into the mantle and the continental plate, the more buoyant plate, is riding over the oceanic plate. Due to tremendous amount of pressure and friction, rock tend to get melt and it form magma at certain depth. Now due to this forming of magma at certain depth, it managed to get uprise and give birth to volcanoes at the convergent plate boundary. There are more than 10,000 volcanoes are present on the Pacific Ring of Fire and they're all active and violent. Now we'll see other characteristics features of the convergent boundary volcanoes. They're mainly violent and erupts without warning. The molten material is granitic in nature, that is mainly acidic in nature, very viscous and thick. The convergent boundaries where the continental plate overrides over the thinner oceanic plate that plays a very important role at the subduction zone that gave birth to the convergent plate boundary volcanoes. The best examples are Mount Fuji in Japan, Krakatoa in Indonesia, and Mount St. Helena in Washington State, USA. Now with the help of thermoconvection cell diagram, we'll understand how the volcanoes take birth at the convergent and divergent boundary. As you can see in this diagram, this is called the thermoconvection cell, where the magma rises from the mantle plume primarily beneath the ocean where the thin oceanic crust breaks apart. These arrows are representing on the either side the divergent plate boundary. When the plate get diverged on either side, somewhere it is to get consumed. As you can see on the both the side of the divergent boundary, they get collide with the continental plate. The continental plate rides over the oceanic plate and due to friction, it also gives birth to the convergent volcanoes. Whereas on the divergent plate boundary also there are series of volcanoes and these are called the submarine volcanoes. Reason? They form beneath the ocean. This sketch represents the complete cycle of divergent and convergent plate boundaries. Divergent volcanoes are quite silent and active, whereas convergent volcanoes are violent and active. Now with the help of a video clip we'll understand how convergent and divergent boundary volcanoes form. Mantle plume, the magma uprise from mantle from deep inside the earth. It breaks through the thin oceanic crust and plates get diverged on the either side. And this plate has to get consumed at somewhere at the convergent boundary. As you can see, this is the thermoconvection cell. In this manner the plate slides on the upper asthenosphere. It also gives birth to the convergent volcanoes. The oceanic plate subdued beneath the earth and the continental plate overrides over the oceanic plate. Due to friction and tremendous pressure, the rocks get melt at the convergent boundary. It uprise and give birth to convergent volcanoes. After understanding of convergent and divergent volcanoes, now we'll know about the third important location where volcanoes are very prominent. It would be very interesting to know that how come the most volcanic places on earth is nowhere near a plate margin. Yes, it is true. Let's understand the third location in detail. Major location of volcano, the third category is over hotspot. Hotspots are mainly the area of great heat in the mantle. As you can see in this cross-section view, from mantle the uprising magma that managed to break through the thin oceanic crust. One of the best example where this hotspot take birth is beneath the ocean. Such condition created due to the concentration of radioactive elements. If the plate happens to be passed over a hotspot, a continuous chain of volcanoes can occur on the Earth's surface. As you can see in this diagram, on the ocean floor, these are the series of volcanoes that take birth. The best examples are the Hawaiian chains of volcanoes. These are mainly in the form of islands, row of volcanic islands named Mauna Loa and Mauna Kea, primarily located at the center of the Pacific Ocean. Now we'll understand in detail how the hotspot volcanoes take birth. As you can see in this visual, the magma that mainly sourced from deep inside the mantle, and this is called the mantle plume, it managed to break through the oceanic crust and give birth to volcanic islands. These are the areas where there is a high concentration of radioactive elements. So these are the mounts of volcanic islands that move towards certain direction. Reason, the oceanic crust relatively move faster than the mantle. Now we'll see how these volcanic islands are formed with the help of a video clip. The magma that uprise from the mantle is called the mantle plume. It breaks through the oceanic crust, thin crust, and it managed to form a volcanic island. As you know that the oceanic crust relatively move faster than the mantle, due to the movement of this oceanic crust, the volcanic island shift little bit towards certain direction and a new volcano will take the place. In this manner, the magma uprise and form volcanic island. And these islands are primarily seen at the middle of the Pacific Ocean. Thank you for watching the presentation.